Landing on a drone ship has become SpaceX's signature move. An elegant solution that turned rocket recovery from rare spectacle into routine. It has cut costs, saved time, and reshaped the very rhythm of space flight. Now, with the rise of Starship, this proven method is set to scale. Official plans from SpaceX and the FAA already point to a future where Starship 2 descends on ocean platforms, carrying the dream of full reusability even further. But how will this method unlock Starship's true potential? And when will it take flight? Let's find out together on today's episode of Simplify Science. It is undeniable that in the past year or two, alongside Starship's impressive test flights, the program has grown substantially in its future operational scope. Several formal proposals now point to an ambitious launch cadence. 44 flights per year from Launch Complex 39A, 25 annually from Starbase, and as many as 76 from SLC-37 in Florida. These numbers signal more than just routine launches. They reflect a broader vision for a higher-frequency global spaceflight system powered by rapid reusability. Achieving this scale of activity will require more than fast turnarounds and robust production lines. The logistics of recovery and landing must be just as refined, especially given that Starship is designed to be fully reusable from the start. Reusable arms are expected to be the cornerstone of this recovery strategy at fixed facilities. This tower-based catching system is central to enabling rapid refurbishment, helping minimize downtime and maximize launch frequency. However, Starship's ambition extends far beyond the limits of land-based infrastructure. According to official documents from the FAA, SpaceX is preparing for Starship to land in distant regions such as the Pacific and Indian Oceans. Notably, splashdowns will likely be avoided as they are incompatible with SpaceX's goal of fast and efficient rocket reuse. Instead, the company appears to be leaning toward a proven solution: drone ship landings. This method has been used extensively with Falcon 9 and Falcon Heavy, and the advantages are clear. First, landing at sea reduces the risks posed to nearby infrastructure and personnel. The ocean acts as a natural buffer for heat, force, and vibration. And in the event of a failure, it offers a far safer outcome than a land-based accident. Even during successful landings, the water helps mitigate the stress of impact, preserving the rocket structure and reducing repair costs. Second, drone ships offer unparalleled flexibility. They can be positioned almost anywhere along a launch trajectory, allowing for optimized return paths and shorter distances between mission destinations and landing zones. This helps simplify guidance, reduces the energy needed to return to a specific point, and ultimately increases the payload Starship can carry. In effect, Starship can carry more and go farther when it does not have to reserve large amounts of fuel for a return to a fixed launch site. These operational efficiencies have already been validated through years of Falcon 9 launches. Scaling this success to Starship, which is significantly larger and more capable, could magnify those benefits even further. Some might even wonder whether introducing drone ship landings could complicate operations at Reusable towers. But in truth, the two methods are complementary. Reusable offers high-speed turnaround at fixed bases, while drone ships allow for long-distance missions, return flexibility, and added safety. Each method enhances the other rather than competes with it. Of course, challenges remain. One of the most pressing issues is international cooperation. Although drone ships can operate in international waters, many recovery operations would require them to enter the exclusive economic zones or territorial waters of other nations. Without the necessary regulatory approvals or diplomatic agreements, recovery efforts could face legal roadblocks. Fortunately, SpaceX is already navigating this landscape. Falcon 9 has been permitted to land near the Bahamas, and recent reports suggest potential collaboration with Australia, which lies near a key landing zone in the Indian Ocean. Additional agreements with countries in South America may follow as Starship's recovery range grows. Another complication is the matter of recovery time. While drone ships can be positioned far from shore, bringing them back with a landed Starship on board could take days. This would naturally slow the refurbishment cycle compared to land-based recoveries. SpaceX may mitigate this with logistics optimizations and new handling procedures. One solution already described in FAA documents is called horizontal Starship delivery. After landing and safing, the Starship would be gently lowered from vertical to horizontal using a breakover fixture. This would simplify transport, reduce structural stress, and make the rocket less vulnerable to rough seas and high winds. There are also engineering questions about Starship's design. Reusable towers are not feasible on mobile drone ships, meaning Starship would likely need some form of deployable landing legs for these missions. While this might complicate the design, it could also prove advantageous for missions to the Moon or Mars. Landing legs will be necessary, especially in early exploration phases where ground infrastructure is limited. By developing the system now for drone ship landings, SpaceX can refine a capability that will be crucial for planetary missions in the future. As the roadmap for Starship becomes increasingly global, flexible and high-frequency drone ship landings seem poised to play a vital role. They offer operational benefits that fixed-tower systems cannot, especially for long-distance or high-energy missions. And while the transition will come with challenges, it also opens the door for broader international cooperation and technical innovation. So, should SpaceX pursue drone ship landings for Starship? Let us know your thoughts in the comment section down below. And if you want to keep following the incredible journey of Starship as it reshapes the future of spaceflight, make sure to like this video and subscribe to our channel. So, when can we expect to see this system in action? Based on all current indicators, the Starship drone ship recovery system is likely being prepared for operations beginning in the second half of next year. The proposals we've seen, such as multiple drone ship landings in the Pacific and Indian Oceans, are all clearly aligned with SpaceX's plans to scale Starship operations in 2026 and beyond. As of now, rapid launch cadence at Starbase still faces hurdles, especially in light of the recent S-36 incident. Florida's Starship infrastructure is progressing, but remains under construction. Therefore, before we see Starship landing at sea, SpaceX will likely continue focusing on perfecting Mechazilla-based landings at fixed launch sites. These arm catches offer more control and enable rapid refurbishment, which is ideal for building experience and consistency. But once those systems are stable and enough data has been collected from control tower launches, the drone ship platform will begin to take on a larger role. That will mark the next big step toward expanding Starship's reach and establishing recovery systems that go far beyond the coastlines. Of course, SpaceX will also need to physically build these next-generation drone ships. Unlike those used for Falcon 9, the drone ships for Starship must be significantly larger and structurally reinforced. Starship itself is more than twice the height and several times the mass of Falcon 9, and its Raptor engines deliver immense thrust. All of this requires a recovery vessel that is robust, stable, and possibly capable of supporting multiple recoveries between returns to port. Beyond the drone ship itself, the broader Starship ecosystem will need to scale as well. We're already seeing signs of that expansion at Starbase. Pad B is taking shape. Massey, after the explosion earlier this year, is being upgraded and expanded. Over in Florida, the LC-39A launch complex is adopting many of the same Mechazilla-style systems from Starbase, and LC-37 is expected to host a massive new platform in the near future. These developments will be supported by large production hangars, gigabays, at both sites, forming the backbone of SpaceX's high-volume manufacturing and launch chain. With these pieces in place, it becomes increasingly likely that we'll see the Starship drone ship system take its first steps by mid to late next year. Until then, SpaceX will keep refining landing procedures, gathering data, and enhancing precision. Only once those systems are reliable will the focus shift toward operations at sea. The end goal is clear. SpaceX wants to match and eventually surpass the performance and versatility of Falcon 9. And fittingly, Falcon 9 itself just helped underscore the effectiveness of this drone ship method by setting new records. At 2:28 a.m. Eastern on July 2nd, SpaceX launched yet another Falcon 9 from SLC-40 in Florida, delivering 27 Starlink satellites into orbit. The mission was a success with all satellites deployed safely. The Starlink network has now passed 7,000 satellites across all categories. Launched in orbit and operational, marking another major milestone for the program. But what stood out even more was what happened below. The booster B-1067 successfully landed on the drone ship, a shortfall of gravitas, marking its 29th landing. This was not just a routine recovery. It was a record-breaker. According to a statement posted by SpaceX, the mission marked the first 29th launch and landing of an orbital-class rocket. Musk followed up with a simple but powerful post, 29 landings of single booster. This flight also marked the 500th mission for Falcon 9, a feat unmatched by any other orbital rocket. It took more than 15 years to reach that number, but SpaceX is now accelerating at a pace no one thought possible. From 2022 onward, Falcon 9 broke past 50, then 100 flights in a single year. For 2025, the company is on track to exceed 170 launches. That level of performance is only possible because of reusability, and drone ship landings have become the cornerstone of that strategy. With 2 active drone ships on the East Coast and 1 on the West, SpaceX can rotate launches and landings rapidly. The current record for booster turnaround is just over 9 days set by B-1088. And now with B-1067 just 11 launches away from SpaceX's target of 40 reuses per booster, we are witnessing the true power of a well-honed landing system. That is why drone ship landings are not just convenient, they are critical to the company's launch cadence and cost efficiency. To celebrate, please reply in the comment section below 500 to 29 to mark this incredible milestone. Looking ahead, the safe return of B-1067 shows us what is possible. If Starship can adopt similar practices, its future looks incredibly promising. Once SpaceX stabilizes the vehicle's re-entry capabilities, it'll be ready to send its rockets farther than ever, perhaps to the Moon or even Mars. But before that vision becomes reality, many challenges remain. Drone ship operations must be adapted for Starship's massive size. Refurbishment cycles must be streamlined, and the ocean recovery process must be carefully choreographed with production and launch rhythms. Even so, all signs suggest that SpaceX is preparing for the next leap. The Starship drone ship system may still be a work in progress, but when it arrives, it'll unlock a new chapter in reusability, one that builds on Falcon's legacy and sets an entirely new standard for what rockets can do. So, let's keep watching, keep questioning, and keep imagining, because when the first Starship finally touches down on a floating landing pad, it'll not just be a recovery, it'll be a revolution. This has been Kevin with Simplify Science. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.